Hi, good morning. Thank you for coming. My name is Rodrigo, or here, like in America, people call me Rodrigo. I'm a software engineer with Walmart. This is the fourth time I come here to HTML5DevConf. It's one of my favorite conferences. Second time as a speaker. And when I was here, 4 years ago for the first time, I was transitioning from working on server-side code to front end, and coming here actually was really important as part of my research, as part of my the preparation for my new project. I saw the keynote was given by Steven Saunders. It was about cache. I learned a lot that day. I apply a lot of things that I heard from him. And today was really cool actually seeing him on stage. And even though I'm researching most of the things that he explained this morning, I still was able to learn as well. So my main goal here is actually to help people by sharing a little bit of my experience, and mainly help people that are still getting around and might be also on the second time here at this conference. As a second goal, I also would like to be able to network with people who are trying to figure out this problem, trying to find different solutions, so we can actually share horror stories and see how actually we're going to fix this. So, just a bit of context, right? So, what's monitoring? Mainly, it's the idea that you want to be aware of a system state and how it's actually how we'll have any changes along over time, right? And so most of the audience here is comprised about web developers, web design. Why we, in this case, why should we care about monitoring? Why should we monitor our code after we ship it? Because our responsibility actually doesn't end on a commit, right? So you care about not only if your application is going to be up, how it's going to be performing, how it's going to be the experiences of the users, if they're going to be satisfied or not with your application. So it's interesting because we, at least as web developers, we are in a unique position, right? Because we are placed between the system administrators who actually own the infrastructure. We own the code, and we have product owners, we have designers, experienced people in contact with the users. So we're sitting in the middle, and we're actually able to get all the metrics that matter for the business. The metrics that tell us about conversion, about user satisfaction, about how our product is doing on the wide, and we can try to translate all those metrics. And we are the only ones that actually can effectively instrument the code to actually try to measure those metrics in every detail. So you saw here, or if you're here and listening to the previous talk from Steve, he was giving a lot of emphasis about custom metrics, right? So every app is different, every system is different, and so you need to work with the business side in order to figure out what are the metrics that matters. And then you have later on the power to have them implemented through your code instrumentation. So how can we monitor a system, right? So how we can define? So it's preview, right? You just need to instrument the application, string all the events to a training system, to analyze, to correlate, and to alert, right? To find for anomalies, try to detect anomalies. So if we try to model, how this is going to be, in a system that has multiple components. So let's say that you would, it's cutting my slide, but it would say that you have your application that's being served by servers, and then you have some messaging system where eventually you're going to string all your metrics to a database. So usually we try to use a time series database because since we are actually observing events that are occurring during along the time, so time series database it's very effective for that because the events are already indexed by timestamp, by the time they actually occur. So as web developers, right, so we mainly focus on instrumentation and telemetry, right? So once I work with the business, once I define what are my metrics, how I gonna instrument my code and how I gonna send that data back to be analyzed. So like we saw before, the W3C has a web performance working group that specify a few, some new APIs, aiming, trying to improve, how we measure time, how we tag events in an application. And this is being part of HTML5, and it's for a while, and it's comprised by a few standards. So let's go through them. So the first of all, the basis is the high resolution time API. So imagine I have one simple object here, one simple JavaScript piece of code that I want to instrument. I have a class here that's a circle and two methods, one that calculates the perimeter and the other one that calculates the area, right? Not long time ago, I was still shipping code like this. So I was trying to measure, how much time, my code was spending actually on the client side on the browser, and I was just dropping, date now here and there. What's the problem without that? Because date now, it's not accurate. The accuracy is milliseconds. So often what I'm going to see, it's actually you won't get any results if you have an event that's happening on sub-millisecond. So enters the write resolution time API. So if the write resolution time API, now you have this interface performance, and we have this method now, where you can use also similar what I was using before to try to time, how much time you're spending during your code execution, and you get way more results, much better results, right? So now we actually see with sub-millisecond precision what's happening. So you have a better comparison on how your code is performing, and you keep tracking all those measurements a long time to see how you're trending in terms of performance, if you're getting better or worse. So one thing about this API, it's the specification says it needs to be like a clock with monotonic increasing implementation. That means that if you call twice in a row, you're never going to get the same value, you're never going to get the same result. That means that if you call in the same, even if you call on the same line, same statement, you're still going to get a time difference. So how is the support today for modern browsers? So let's say that with exception of Opera Mini, we have a very good support for current browsers. And even when we talk about market share, you can see that we have over 80% of support for this API. So it's good to, so I would say that if you're targeting these browsers, you probably are good to ship this to production. Another very important API is navigation time API. So the navigation time API actually tracks many events that happen when after you go to the browser and navigate to one particular URL. There are lots of events that are being tracked, and you get, again, with sub-millisecond precision, when they happened, what was the duration, and so on. And there's some, even some very important events that you can see here that actually can give you insight not only about how your application behaves, but even your infrastructure is, how long it's taking now for DNS resolution, how long is this TCP latency. This actually also helps us to figure out if the infrastructure they have in place, it's enough for give us a good performance. So how this is implemented? Again, it's on a performance interface. There's now an object called timing. When you call this object timing, you should have, Unix timestamp for all those events that were represented before on that graph that's showing, during the process of loading that particular page, what's happening. How's the support for this API? So again, for current browsers, it's really good. No exceptions, Opera Mini. If you think about in terms of market share, we have over 84% of support. The resource time API. So the navigation time API tells me, how long it's taking for the page to load. So the first document that I'm trying to retrieve when I make the HTTP request. The resource time API is going to tell me each resource that's loaded after the document, like every CSS file, every JavaScript file, every image, web phone, and even later on AJAX requests that are making, how much time they are taking. So when you call, in order to retrieve those values, on the performance interface, you have now a method called getEntriesByType, where you can filter what type of object you want, in this case, resource. And then you have, again, all those times information that you had before for navigation, for the navigation time API, plus also who initiated the download, what resource I'm talking about. So here things start getting worse. So in terms of current browser support, it's still not implemented yet by Safari and by iOS Safari. But in terms of market share, you still have nearly 70% of support. So by now, you probably figure out that by using these two APIs, by leveraging these two APIs, we actually have enough information to reconstruct something like a graph like the one that we see on the Chrome DevTools or equivalent DevTools. When you have a timeline of all the resources that the application is loading, the times involved, when it starts, duration, and so on, by combining those APIs. And again, same thing when you talk about sometimes we need, because when you're using the Chrome DevTools, you're actually debugging something on a machine. And then if you want to see how it's actually behaving on the wide, the best tool today to try to do those measurements is the web page test, right? But again, because you can actually ship your instrumented code to all your users to try to retrieve that data, that means that you can actually reconstruct later on that data, not only for a single user, but for all your user base. So you have a much more detailed idea, how your application is behaving, with different browsers, different types of computers, across the globe, and so on. So this allows you actually to collect way more data in order to have a better understanding of how application behaves and how your users perceive it. The user time API. So the user time API, remember, so far, all those APIs, they bring us information about everything that's happening until the page and most of the resources are loaded. But modern applications, they are mainly single page applications. After the initial page load, you still have code that's being executed. The application transitions to a single page app mode, and then you still have user interacting by clicking, navigating, downloading content. You still have your application being re-rendered all the time. So how do you measure those custom events that are happening after page load? So we instrumented using adding marks. So let's say on this particular example here, I'm adding a mark before calling implementer, after calling implementer, and then there's a method called measure that when you pass 2 different marks is going to create another entry with the duration for the 2 different marks. Not to retrieve that entry, use the method get entries by type again, but now you set the type to measure. And what you're supposed to get is an object that has, like, when that particular operation started, since the first page navigation, and how long was the duration of it. So browse support, similar to resource time API, is still not implemented by Safari and iOS, but in terms of global market share, it's still close to 70%. So last one is the beacon API. After our page is loaded and we start getting those metrics, we need to send those metrics back to a server so we can later on stream to our time series database. The problem was, in the past, if the user was navigating away from your page or was closing the tab or the browser, you might lose data. You might lose metrics. You might not get, or at least we might not get them sent to the server right away. So with the beacon API, what happens is now you can actually listen to the unload event, and you can call the beacon API to send the data via XHR back to the server. Before, the servers, if you just try to do a regular, ordinary XHR request, before the beacon API, what would happen was the server probably would not fulfill your request, and you wouldn't get the data back to the server. But now, with the beacon API, so not only you can do it after the user is navigating away from your page, but this interface even will confirm to you, so it should return true or false if it was successful or not, if it was able actually to send the data back. If it fails, so we can actually try to store those metrics in the local storage and try to send again next time the user visits your page. So the beacon API is still not implemented. So it's not implemented by Safari and Safari iOS. It's not implemented by Internet Explorer Edge, but it is already. I took this from the canaries.com, So this is actually not updated. On the Edge backlog, they already added this API to be implemented next. So next release of Edge should have this, should support the Beacon API. How about polyfills? So there are a few polyfills for some of the APIs. You know that none of those APIs actually, none of those polyfills can actually give you the same benefits of the native API, because you know everything is based, for instance, on the high resolution timer, and if you don't have that, so you're gonna lose most of the information anyways. So my personal opinion is I would not recommend using polyfills, because the only reason my use today is actually to not have your build break. My actual recommendation is actually do feature detection to see whether or not you could use those APIs. You saw that besides the Beacon API, all those new APIs, they are all about timings and durations. Why we are so obsessed with timings and durations, right? So since 1902, so there was this seminal study by IBM that was correlating, user productivity to system response. And I guess that was the first study I saw about this, try to figure out this correlation. After that, you're going to find dozens, maybe more, of similar studies, not only correlating user productivity, but also conversion to how your system responds, also user satisfaction, even how your user sees your system, if he perceives your system as a powerful system, or if he perceives your system as an underpowered system. So it's at the end of the day, it's all about how fast you can allow the user to start interacting with your system, with your application. So we have all those new APIs that we can use to instrument our code, right? So how we can instrument the code then? So we could actually take one page from older platforms and ecosystems like Java, .NET. They're doing this for years. So what you usually want to do is you have your source code. That's pure. It's a snowflake. And you don't want to drop performance now here or performance measure there. You don't want to touch or change your original source code. So you want to be able to instrument it without changing. So one way we can do it is actually by using AOP. In JavaScript, we can actually hack or modify objects during runtime really easy. So it's actually, you can write your own AOP library in like 100 lines of code. This example here is just using Meld because Meld was the most popular on GitHub. But the way that you usually implement you could implement instrument your code using AOP would be like you define a point cut before your method is called, and then you add a mark, like here, performance, circle perimeter before. And then you want to define another point cut after the method is called. And then you instrument it, add another mark for after, and then you do the measurement. So if you instrument your code like this, next time you call it, so let's say that you have the same object, now I'm calling, you don't see the instrumentation here, but the object is already instrumented. So what's going to happen is you call it, you try to retrieve the entries that you measure. You should have an object like this. So you have the duration and when it happened. Well, but it's already 2015. We're looking forward to 2016. JavaScript is changing. There's this new feature that's coming soon that's decorators. But it doesn't matter when it's coming or not. Everybody's transpiling their code nowadays. So it doesn't even matter if this is eventually going to make to the final specification. We can write code using it today. So let's say this is how a decorator looks like. So what do you need to, why you can pay attention here is, it's pretty much, it's a function that takes a targeted object, an attribute that's the name for one particular property, and a descriptor. So what we're doing here, like with less than 10 lines of code, it's similar to AOP, but what we do, we add a mark before calling the function, the real function, add another mark after calling the real function, and then we do the measure. And then, if I rewrite my source code using ES6, I can do something like this. I can actually add decorators to the methods that I want to have instrumented. So I'm technically here actually changing my original source code, but it looks clean, it looks clean, even self-documented. So it should not be difficult for the developers to get a grasp on that and maintain this. So if I have the new code rewritten in ES6, or actually ES7, using the decorators, if I try to call that code once after I transpile it with the instrumentation, you should get be able to retrieve the measurement entries after executing. So going back how we are modeling our system end-to-end. So again, you have your application, and at some point, you have your analytics, where you're gonna where you're gonna graph the numbers, where you aggregate, and so on. So I have like a quick demo here, where I took like the to-do MVC from the Facebook Flux repo. I have a Node server, RabbitMQ, InfluxDB, and Grafana. And you might think, well, but we're talking about 1 to 5 components. It's a very complex system, for me to try to get grasp about, instrumentation and monitoring. Yeah, but by leveraging containers, like from Docker, you can actually have all the components of this system actually running on your laptop. So think about, we as a web developers, most of our days actually changing the source code, going in one window, and then going back to another window and checking, what changed in the browser, right? We have a workflow that we keep interacting with the code and see the results. So we can actually have a similar workflow also for monitoring, for instrumentation, for defining metrics, and how we actually visualize those metrics, and how you change your code, and how this affects those metrics. So you can have your code running, and you also can have your analytics running, everything on the same machine. So let's do a quick demo. a different way. Sorry. So I have this repo where on the root of the repo I have a Docker Compose file. And in this Docker Compose file, sorry, having some trouble to zoom here. No, not this. So, can you see from the back? 1 second. No, it's not zooming. Thank you. Thanks so much. So this is a Docker Compose file. So if you never tried before Docker, so what I would suggest to you is actually to go to their website and download. There's a toolbox, Docker toolbox, that comes with several tools. One is the Docker Compose. The Docker Compose allows you to set up a system that has multiple containers. Another thing that you're going to have is a Docker machine. So if you're using a Mac or a Windows laptop, so you're going to need a Docker machine because containers is a feature that's actually it's native from Linux. So and in order to have that working on a different operation system, you need actually a virtual machine. So get a toolbox, and then you're going to have all the components that you need. So in the case of the Docker Compose, you create a YAML file, and the YAML file you can actually define what are the pieces of your system, what are the containers that you want to get up and running. So I have here like one app, which is my Node server, that is going to build. It's going to build the context of the app folder, and it's going to link to InfluxDB, which is the time series database that I chose. And then later on, I have Grafana, which is the graphing tool that I'm using to plot the results. If you look into the app itself, it has a Docker file, and it's called Docker file. It's pretty trivial. The only thing that tells is what version of Node that I want this container to be built, and what port I'm going to have exposed later on. So this app, it's a simple web server using Happy. Can provide variations with Express. You can use whatever you want. And the Flux to do MVC available from the GitHub, Facebook Flux repo. It's a fork from there. In the server side, we're doing just a few things. Like I'm registering a few plugins. One is for serving the static files. I have also couple plugins to tag every request with a visitor and visit cookie, and another plugin that measures every page hit and also records every page read and streams the data. So Flux, the reason why I picked that particular implementation of the to-do MVC, it's because I needed one that actually was using ES6 or 7, was already using Babel for transpiling the code, because I just drop the instrumentation without having to rework the code, refactor the code. So that's a simple to-do app where you can add things here like wake up, trash. Nothing different than what I saw so far, right? And then on the same machine, I have the database where all those events are being streamed. And it's not zooming. So I have a database called to-do MVC, and if in Flux we have this admin UI where you can, for instance, see what are the tables that I have, what measurements and metrics are relevant for me so far, what I added so far. And we have a Grafana instance here collecting the data to where the data is actually being streamed. All right, so I have a few metrics, page reads, page fails, resource duration. This is actually coming from the client. So we have under to-do MVC at the top level, there's a render method. You see here how long it takes actually to create the React element object every time the page is refreshed. So it takes like less than 1 millisecond. And this is actually being measured on the client side. And if it wasn't for the new APIs, you wouldn't have this resolution. We would be missing this. See if this is going to work. So I'm going to change the code of my So I apologize if I never saw the to-do MVC source code or even ES6 before. One thing that comes extra with this implementation, they're using Flow. So it might be a little bit weird. So on the app itself, there's so you have this input box when you add all your to-dos, right? And whenever I enter a text there, this save method is called. So we're gonna mark. I'm gonna say to do created. And now hopefully everything is running. We could do again. Full bar was Oh, I forgot to refresh. So now my code is instrumented. I had to refresh to get the latest. And we can go to the database. So we have the marks table. And the data is not there. That's why you should not do a live demo. Full var path. Okay. So the application actually, I set it to send the metrics every 15 seconds. So the frequency that you were going to send the metrics back to the server, you have to be sensitive to your users, right? So you don't want to use the send the metrics all the time, because we have to be sensitive to the connection limitations and so on. Also, how many metrics you're gonna be collecting, you have to be mindful about that. It's not just because you can do something like collect tons of things and send back to the user, that means you should. Remember that when you add the instrumentation, you're also adding some overhead to the code itself. So depending how much overhead you're adding, it's not something that you could drop this entirely. One solution is actually try to A/B test. So you have different builds. One build's instrumented, another build's not instrumented, and then you can figure out what your users are going to get, which versions they're going to get. So let's see last time if it's coming. Name equals no. Well, anyways, if I had the data coming all the way to my database, you could later come here to the Grafana instance and add another chart and figure out how many to-dos were created, which rate, and then you can figure out by this, what's their conversion, right? So from this basic instrumentation techniques, you can actually figure out how you're gonna get the metrics that the business really wants, and the developers are the only people that actually can do it. That's something. Yeah. So that's it. I hope this was helpful. I guess we might have 2 minutes for questions. So I'm gonna create a repo called Monitor for the Masses. I'm gonna tweet the slides first. I need to figure out why the demo is not working, and I'm gonna make the repo public. If you don't care, you just ping me. I can give you early access. If you help me fix it, I buy you coffee. And that's it. Questions?